Let's see if we've got some in the book we can do. Some cool ones that I like here. Let's use some different variables, shall we? Let's see, I've got z minus 4 equals minus 3. And we talked about multiple signs earlier on. What do we want to do with those multiple signs before we go ahead and jump into this thing? Okay? Let's reduce some of the signage I got going on here. So a negative times a negative is a positive, right? So we can simplify this bad boy up. Okay? Now what are we going to do? Here's my variable, no longer an x, it's a z. So what am I going to do to both sides to equalize this thing? Subtract. I'm going to subtract 4, right? So if I subtract 4 to both sides, I get z equals. Now I got two of the same signs. What does that mean? I'm going to add and take its sign. So if it gets 4 degrees below 0 and it gets colder 3 degrees, or the elevator goes down to the 4th level below the mezzanine, and then it goes 3 more levels below, you get down to minus 7. So there's my minus 7. Okay? All right, let's try this type of problem. Let's do another different kind of one-stepper. These are all one-steppers. Why? I'm only doing one step. What if I had this? 3x equals 9. Now I'm going to isolate the variable by what's next to it. But there's no sign next to it. So if there's no sign next to it, what's assumed? Multiplication. So you can either put a dot there if you like, or you can just multiply with parentheses, I suppose. You can set it up like this if you like, so tell yourself you're multiplying. So I'm going to do the opposite of multiplying, which is dividing. So I'm going to divide the same thing to both sides. So what am I dividing both sides by? Why am I dividing both sides by 3? Well, if I'm multiplying by 3, then I divide by the same factor. Okay? So I got these canceling out, or 1. They turn into a gigantic 1. And Keith was asking about that earlier. Right? So if I have x equals 9 divided by 3, stay with me. I know it's kind of easy, guys. You know, so far it's pretty easy. I'm moving kind of slow. Oz, you with me? Stay with me, my man. Okay? Take notes. It keeps you alive.
No, I am.
You got this last one?
No, not that one.
Okay. Stay alive here, because I'm about to turn the corner. This roller coaster is going to get rolling, and if you miss it, you miss the smallest little feed-in, you're dead. As far as getting the right problem. Okay? So I'm going to change this up a little bit. Stay with me. Okay? What if I had this? You want to divide by 3? Multiply by 3, both sides? So if I multiply by 3, I get 9, right, over x equals 27. I did get my x alone, did it? Why did you say that? That's not the right thing to do here. It might be a way to do it. It's not wrong. You didn't really equalize anything. So what's going on next to the x?
What if you put a 1 under the 9?
Same thing. If I put a 9, multiply or divide by 1? Is that what you said? Multiply?
What's that? 3?
And multiply by 3? Multiply by 3? I still got 9 over x equals 27. It's got the same thing. Didn't help me a whole lot. Oz? What do I do here? He's preoccupied over there with that calendar. I'm trying to get you, I just turned the corner, I'm just wondering if you're following me or not. If you don't know, you don't know. That's okay. I didn't expect you to know. But I want you to follow me. Right? Stay at my wing. I'm the lead guy and I'm the lead bird, right? When the lead bird takes a turn, what happens? You're going straight. Right to a wall. And that's what you just did, didn't you? Crashed into a wall. So the lead bird is out there going, okay, stay with me, stay with me. Take a turn. And all of you just smashed into a wall just now, didn't you? You're all with me going, yeah, I know this, I got this, I got this. You're all telling me, oh yeah, I got this, look at it. I'm gonna have a little discussion right now because I got this. I don't think so. Maybe.
You know,
And Oz used to, oh, what's that?
You don't do 3 times 9 is 27, 23 over 27?
Say what?
3 over 27? And then
3 over 27? What? Huh?
to
You're
say-
doing the mental math in your head a little bit. But 3 over 27 is still not 9.
Okay.
Good try. Thanks for playing. Yes?
What if we put 1 over 9 and then
1 over 9. You mean this?
and then
Oh.
cross multiply?
I know what you're trying to do. It's called a cross product. And you're putting the 9 over 1 and cross product. So if I do the cross product, I get 9x equals 3. Cross product means multiply. Now I can solve for x by doing what? Divide by 9 both sides. Which is what some of you were trying to tell me, but not in the right manner, I guess. So you got x equals 1/3. Good suggestion there, Casey. Nicely done. Okay? Let's do another one of those. See how I handle it. Let's say I've got 5 over y is equal to 15. These are all still part of the one-step family. But these are the tougher ones. I've done my click, 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 and now I'm starting to roll down a little bit. A little small hill right now. Any ideas? Oz, you may want to recover from this one, no? You want to do a little recovery action? You interested in recovery? What would you do here?
Same thing, but
Same thing, but what same thing? But what? Trying to get you in the action, my man. Come on. Come back in. Come back to me. Still flying up there. Getting a little higher now. I'm in some clouds. Got to stay with me. Anybody want to chime in? Oz still seems to be struggling to get the move here. Put 15 over 1. Just like I did here. This was the action I did. And then what am I going to do? I'm going to cross multiply. I'm sorry. Cross product. This is called a cross product. Not cross multiply, cross product. Cross product is different from cross multiply. We talk about cross multiply when we're multiplying fractions. They were top to top, bottom to bottom, like railroad tracks. These are not railroad tracks. That's X marks the spot right there. And so that's called cross product. So if I do the cross product of these two guys, what do I get? 15y equals 5er. Divide by 15. And I get what?
1/3.
Bring it backwards. Oh, I got the 11. I got the equals backwards. 1/3. This is Leonardo da Vinci again. Jump right backwards. Okay, 1/3. Check it. How the heck am I gonna check this bad boy? What the heck? I got. Oh, let's try to check this bad boy. Let's see. Why don't you try to check it first? So if I'm going to check it, that means I'm going to get 5 all over 1/3. Is that equal to 15?
Yeah.
Don't want. Good answer to get me to back off of that one, huh? Very clever. Nicely done. Anybody, any ideas for the peanut gallery here? How do I check this thing? Megan, you got some look on your face like you think you got it.
Can you put the,
No? Okay, so now you're all starting to chime in, but only one at a time this time. 5 divided by 1/3. This is a fraction. 5 over 1. When we divide fractions, what happens? Flip the second term and turn multiplication. So I got 5 times 3 over 1, and indeed, check, check. We're good to go. So we're using some old information to help us with these. Again, that's part of the clicking process that we did. Those fractions, those goofy fractions. The reason why I dragged you through the mud on fractions is because so you can help yourself correct these. There's a method to my madness. Okay? So, okay. So that's how you do these. How about another one? What if I had this? Let's see here. Minus x plus 5 equals 3 halves. What did I do here? Still a one-stepper. I'm only really doing one step. It might be kind of a 1.5 step is what this is. So I'll do. Okay? So I'm still going to subtract 5. That's true. Still going to subtract 5. So if I subtract 5 from both sides, I've got to do my fraction business. Right? So I've got to get common denominator. Let's make common denominator what? 2? Let's make it 2. So I've got 10 halves. And I'm subtracting this. So I got minus x equals, what is this? Oh, man. Well, I got negative numbers, so I'm going to pretend it's a negative number. So minus 10 plus 3 is minus 7 halves. So I get that. Am I done?
No. Divide x.
Hang on a minute, hang on.
I mean, not divide.
You got a question?
I was going to tell you. should
Tell me what. Talk to me.
Do another step to get the negative off x.
What's that other half step?
To divide.
You could divide or multiply. Doesn't make a difference.
Yeah.
So a lot of people like divide by minus 1, and you can divide this by minus 1. You could also multiply by minus 1. Gives you the same result.
Can we rewind just 1 second to that 10 up there? Where'd that come from?
5 over 1 is the same as minus 5 over 1 is the same as minus 10 halves. I found an equivalent fraction to be able to subtract the 3 halves. Okay? So now my result, I'm doing twice here, but my result here is positive 7 halves. Yes? Everybody agree with that? See what? Well, that's a good question. Because remember I said something about you can't have negative exponents? Well, the same reason here, you can't have negative values for x. So this is a short little trick to get rid of the negative sign off the x. You don't want to have negative answers. It's like me teaching negative, you know, like Eeyore from, you know, from Winnie the Pooh.
Are you okay with that?
So you don't want to teach. So the same thing with negative values. You don't want to get negative answers. You want to make everything positive. Right? Kind of like your math teacher. Okay, so basically I got x equals 7 halves. How do I know I'm right? Let's plug it in. So if I got 7 halves here, it's a negative.